Cisco clients. For example, you could be using a Cisco IP phone 7970 version as your phone. You could be running Cisco IP Communicator on your PC. You could be, using the Cisco VT Advantage video solution as your video streaming client. Those are all could-bes, though. The benefit of this is that even though we might be using a Cisco Unified Call Manager to manage all this, these don't have to be Cisco clients. Maybe you found some other vendor that made better or cheaper phones that you wanted to buy for your organization. Thankfully, this is being designed and is being moved into a model where those non-Cisco phones could work with the Cisco call processing infrastructure. And let me actually move down to that layer, because that's a good core to begin from. Call processing in the Cisco world, at least in the normal Cisco world of businesses that we're talking about, is going to be the Cisco Call Manager, or I'll just put CCM, Cisco Call Manager device. Now, Cisco does create other call processing devices, some for a small business, like they call it Call Manager Express, runs on a router. Some for extremely large service providers that you can use, but Call Manager is the core product that they use to fit into mid to large organizations. And now even new ones are coming out that will fit small organizations. I have a habit of getting ahead of myself in this. But you could be using this for your call processing, meaning when somebody dials, this is what tells what those digits mean. This is what makes another phone ring. This is what routes you off to the PSTN. There are infrastructure components, and whenever you think about infrastructure, you should be thinking about the routers and switches that we use to make everything work. We have switches that our phones are connecting to, routers that connect us off to the PSTN. Those infrastructure pieces could be Cisco or they could be some other vendor. Applications, these are things that enhance our network. For example, you might run a call center and need call reporting functionality to where you track every single call that's going through, how many minutes it took. You have recorders that kick on when somebody calls. You've dialed somewhere and they say, this call may be monitored for quality assurance or quality service. And they actually record the call to review it at some later time. Those are all separate applications which, again, could be made by Cisco or they could be made by somebody else. You see what's happening here? Even though this gives you an idea of Cisco becoming the Borg, they're actually becoming everything but. Really. Because when they're moving to Call Manager, you are just talking about a management infrastructure that can manage any vendor's type of equipment. Now, a lot of this I say with my fingers and toes crossed. Because I've been in this voice over IP world for about 6 years now. And when it first came out, everybody was talking, oh, voice over IP, it's the future, everything's going to be just like you're describing, Jeremy. It's open source, everybody can use everything. But all of the vendors, that jumped into the voice over IP world, Avaya, Cisco, 3Com, all of these different vendors created their own proprietary protocols. And people just were thinking, ugh, what is that all about? You had things like MGCP, which Cisco tried to create and make an open standard, but nobody wanted to use it. And then you had this thing known as CIP. You may have heard of that before if you've taken C-Voice. CIP was supposed to be the be-all industry standard for everything. But CIP wasn't done. It was a brand new protocol when it came out, and it didn't offer anywhere near the features that people needed. So everybody started creating their own proprietary plugins. So the result was, if you bought an Avaya phone and you plug that into a Cisco Call Manager system, it would get dial tone, and it could make a call. You could dial some numbers on that phone. But if you went and tried to do a conference call, or maybe push the hold button, or transferred somebody, it wouldn't work. Those buttons don't work because those weren't part of the original CIP standard. And I'm just picking features. There are all kinds of things that our phones can do nowadays, and we need a standard protocol. Thankfully, CIP is now evolving to become the protocol that everybody wants. We'll come back and talk about the protocols a little bit later in this series, but for now I want to turn our focus to the Cisco Call Manager. The Cisco Call Manager has gone through a variety of versions and a variety of even name changes. It started as the Cisco Call Manager back in version 2. 3.4. That was the original release of Call Manager. It then, in around the version 4.0 realm, made a move under Cisco's Unified strategy and was renamed to the Cisco Unified Call Manager. And now they call it Cisco Unified Communications Manager. And then they put in parentheses Call Manager after it. So it's almost like the name itself just keeps getting longer. So if I say Call Manager throughout this series, think Unified, think Communications Manager, think all the different flavors of Call Manager that have been released. They all focus on the same thing. They are the mind of the voice network. They are the intelligence behind everything. When you pick up a phone, the Call Manager is what gives that phone dial tone. These Cisco phones, I have one sitting right next to me, as beautiful as they are, if they don't have a Call Manager, they don't do anything. They just sit there. There's no dial tone, there's no screen, it's dead. So they are the intelligence and the power behind your voice network. The functions you can see are call processing. When you make a call, the Call Manager processes that. And I want to give you an idea of just at least these first two functions by looking at this network below. Simple network, two phones plugged into a switch with a Call Manager. As soon as this phone goes off of hook, it's as if the phone runs over the Call Manager, runs across the network and says, Call Manager, somebody just picked up the phone, what do I do? And the Call Manager says, whoa, it's all right, calm down, breathe easy. Just go ahead and play some dial tone. And the phone goes, and you not even thinking anything of it, hit the button, the 9 button on the phone. And the phone immediately runs out and says, Call Manager, somebody hit a 9, what do I do? And the Call Manager says, well, okay, it's all right. Sends back a message, stop the dial tone, play a beep. And the phone goes, beep. And that's what we hear on our phones. Every single thing that the phone communicates to the Call Manager, and by the way, by default, this is through a protocol called Skinny, Cisco's Skinny protocol, and that's communicating up to the Call Manager. Everything the phone does is controlled by the Call Manager, almost like a mainframe environment, to where the phone has no intelligence of itself. Now, the dial plan administration is also in the Call Manager, so if this person dials 9512, which happens to be this phone over here, the Call Manager receives that, looks it up, and says, oh, this MAC address has that, so I will send a ring signal, that's the signaling, to this phone, and the phone says, oh, I just got a ring signal, let me ring. Somebody picks up, and then the phones themselves will communicate directly and stream audio between each other using a protocol known as the real-time, it's real-time, transport protocol. That is the audio itself. Now, thankfully, the Call Manager doesn't get involved in RTP processing, because if